Alright gang, today we're going to be talking about a little bit of a twist of what we did before, and that is some advanced formulas with trig, particularly the sum of cosines. So let's start off by reminding ourselves of what we already know about evaluating trig values and kind of work from there. So cosine of 0, we recognize that as being right there on the axis. We know that that point is 1, 0. Cosine is the first value. Cosine of 0 ends up being 1. 240 is a little bit trickier. I know that that's going to be 60 degrees beyond 180. And I already know my rules for the 60, so that's going to be a root 3, and that's going to be a negative 1 and a 2. I know it's not on the unit circle, but it makes my life easier. So cosine is going to be negative 1/2. Cosine of 75. When I go to make this one, it's a little bit more annoying because it's in quadrant 1, but it doesn't have any of those awesome stops. It's not on a quadrantal, it's not a special right triangle, so it's really kind of a dead end of how we deal with it. So horrible that in fact we need new formulas. Ta-da! Sum of cosines. Sum of cosines can be used whenever you have two ideal angles added together. This is a subtraction version also. So 75 is an ideal angle of 30 plus an ideal angle of 45. Those are both good angles because I know a lot about them. I already know their reference triangles. I already know their attributes. So now I can tackle more and more problems that otherwise I'd have to reach for a calculator if it's not one of those ideal 30s or 45s or 60s. In order to do this, I just have to do some more writing. I take the cosine of the first angle times the cosine of the second angle minus the sine of the first angle, sine of the second angle. Once I put that all together, I get myself an answer. And now I get that exact problem. So cosine of 30 plus 45. So I take my cosine of 30 times my cosine of 45 minus my sine of 30 and my sine of 45. So it might be helpful to have a little 30 to point at. So for my 30, that's a 1, that's a root 3, and that's a 2. So my cosine is going to be root 3 over 2. My cosine of 45 is a separate reference angle. It's just 1, 1, and root 2. Or you might recognize it as root 2 over 2. Sine of 30 is going to be 1/2. And sine of 45 is the same as cosine. You're going to find with these sum and difference formulas, you tend to get a lot of the same angles over and over again. And that's going to make the answers look pretty similar over and over again. So I'm going to write my answer as that. If you really want to, you can combine them together into one fraction, but I'll accept either version. So let's try cosine of 105. Cosine of 105, the first thing you want to be able to do is split that 105 into two angles that you're comfortable with. The fact that it ends in a 5 means that one of my angles is probably going to be 45. So I'm just kind of spitballing here, but ask yourself, what do you add to 45 to make 105? And that's 60. So now I got A and B. So I can take cosine of 60 times cosine of 45 minus sine of 60, oops, it's a horrible 0, and sine of 45. So again, this is why we do the Mad Math Minutes. This is something you should be able to generate quickly. Cosine of 60 is going to be 1/2. 45 is root 2 over 2. Sine of 60 is root 3 over 2. And sine of 45 is root 2 over 2. Put these together, and look at that, I get some of the same players. Those numbers tend to be very popular in these problems. You just got to figure out the order that they play in. All right, so we're going to try and find the exact value of 345. The exact value is really just reminding you not to use a calculator. Push came to shove, if you had access to a calculator, you could just punch in some buttons here and get an answer. But we're going to try and get it using our rules. Now, I see this 45 straight off the bat, and I could actually think about this as 300 plus 45. There's more than one way to split this up. It's just that's the first one that I saw, so I'm going to run with it. So that's the cosine of 300. Cosine of 45 minus sine of 300, sine of 45. 300 is a little weird. It's going to be all the way out here in quadrant 4, coming around to 300. But I know that little reference is 60. Once I know that, I know how to populate this guy, and I've got a better idea. Note, because we're in quadrant 4, that my root 3 should be negative. So my cosine is just 1/2. 45. We've done that twice already. We've got that memorized. Sine in this scenario is going to be negative root 3 over 2. My sine of 45, same old story. And now I got myself root 2 over 4 minus negative, so plus root 6 over 4, and that's my answer. All right, so exact value of. Radians are a lot more obnoxious in these problems. This is a nice problem because they separated it out, and you know what A and B is pretty obviously. Degrees you can split apart okay. Radians splitting apart is really horrible, and you really want to avoid it if possible. But they've already split it for us, so we're okay. We know that that is cosine of pi over 3, cosine pi over 4, minus sine of pi over 3, sine of pi over 4. So now all we want to do is figure out what this is going to be. Sorry, I was just interrupted, and I have no idea what I just said. All right, continuing. Pi of 3. So I'm just going to make a little triangle right here. Remember the pi is 180, so that's really just 60 degrees to be able to put this together. So cosine of pi over 3 is going to be 1/2. Sine of pi over 3 is going to be root 3 over 2. Pi over 4 is my 45. So I'm just going to put that together in the same style. So what do I got? I got root 2 over 4 minus root 6 over 4. Again, I get that same kind of format tends to pop up very often. The sign in the middle changes, but usually it's those same pieces in your answer. Okay, so this problem's a lot scarier. It's going to be based off the same idea of the last problem, but in this one, you've got this idea of a put together radian value. So this value right here represents some angle A plus some angle B. I just don't know what they are, as easy as it is with degrees. Now, I do know that in every problem we've done so far, one of them was 45. So I'm going to take a wild guess and assume that one of these is pi over 4. So somebody added pi over 4 to something to get 5 pi over 12. In order to get a 12 on the bottom, the other denominator would have had to been a 3, so that kind of plays out. When I kind of back solving this, if I were to add two fractions together, this one would have turned into 3 pi over 12, so they'd have a common denominator, which means this one would have to turn into 2 pi over 12 in order to get that 3 pi and the 2 pi. So I need to make 2 pi over 12, and I currently have something over 3. This is not going to work out all that awesome, because to get from 12 to 3, I'd have to divide by 4. To get from 2 to blank, I'd have to divide by 4. So I'm actually trying to put a 1/2 in that spot. That seems pretty stupid at first glance, but I could bring that down the bottom and say this is actually pi over 6. So I was wrong about the 3, but at least it gave me a place to start, and now I've got my two setups. If you check that pi over 6 plus pi over 4, it will indeed make 5 pi over 12. So now I know my A and my B. As you can imagine, this is a lot more annoying than working with degrees. So alternatively, if you want, you might want to take this starting problem and turn this into a degree, and then split it up as a degree problem. I think you're going to find splitting it out much easier in degree form. But we're here, so let's just roll with it. Cosine pi over 6, cosine pi over 4, minus sine pi over 6, sine pi over 4. And then just for quick reference, 180 divided by 6 is going to be 30 degrees, so that's my 1, my root 3, and my 2. My cosine is going to be root 3 over 2. My cosine of pi over 4 is root 2 over 2. 1/2, root 2 over 2, root 6 over 4, and root 2 over 4. That's my answer. All right, so this is a little bit more theoretical. I'm going to try and figure out the cosine of alpha plus beta. I know alpha is in quadrant 1, so let's talk about alpha first. In quadrant 1, I'm just going to make a blank reference triangle. I know that the cosine of alpha is 1/3, which means that I know the x value is 1 and the hypotenuse is 3. I could do a little bit of Pythagorean theorem to realize that this side is root 8. That's my alpha triangle. For beta, I know that beta is actually in quadrant 2. Beta's got a cosine of negative 3/5. So my x value is negative 3 and my hypotenuse is 5. Let's see, what is that, 4? So now we've got all three attributes of both triangles. Now that I know that, I can put together the basic problem. because this is a sum that's cosine alpha, cosine beta, minus sine alpha, sine beta. Cosine of alpha, they told us is 1/3. No thinking there. Cosine of beta, they told us was -3/5. Sine of alpha, we actually have to think about. That's the opposite over the hypotenuse, so that's √8/3. Sine of beta is the opposite over the hypotenuse again in the other triangle, so that's 4/5. And notice that we get a deviation from that formula that we've been seeing over and over again. √8 we can pretty up if we really wanted to. And that's my answer. The moment that they start giving us values for cosine or values for sine and the setup, we get away from that classic solution. That classic solution of the √2 and the √6 is just when you get a cosine of an angle. All right, so same style problem, we just have a new setup. So I've got my alpha, it's going to be in quadrant 4. And I've got a cosine of 1/5, so that's 1 and 5. 25 minus 1 will be square root of 24, which is going to be 2√6. My beta is also in quadrant 4. -7 and 25. So this time it's actually a sine. So my y value is -7 and my hypotenuse is 25. I don't have a calculator handy, but I'm pretty sure that this other side is 24. Feel free to correct me. So now I've got these two ideas and I want to put them together. So I got my cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. If you absolutely hate the Greek, you're welcome to say x and y or x and theta. It doesn't matter all that much, as long as you make sure you match them up correctly. Cosine of alpha is 1/5. Cosine of beta was not a freebie. It's this 24/25. Sine of alpha is our ugly 2√6/5. And sine of beta was -7/25. And so what do we got? 24 plus 14√6 all over 5 times 25. Optionally, leave it as two separate fractions. I'm just lazy. All right, so we're going to attempt to prove that this equals that. I know how much you guys love identities and you enjoyed that quiz, so here we get a chance to prove it. To prove this, this is my A and this is my B, and I just want to run the formula. So that is cosine of A, cosine of B, minus sine of A, sine of B, for my left-hand side. This is also where it's nice that you actually use the given symbols as opposed to populating with your own symbols. If I use the given symbols, it fits together a little bit easier. But I got to remember what's going on at pi. At pi, all the way over to the left, that coordinate is -1, 0. So cosine of pi is -1. Sine of pi is 0. So this whole right piece just drops off the problem. And I get -1 times cosine, or negative cosine x. Proof. All right, folks, that's all I got. There's a new homework packet, and I hope you enjoyed playing around with law of cosines. Have a good one.